Hey everyone, so what we're going to be talking about for our first part of today's class is traveling a network. The first subject we want to get into is a walk, and so these are all going to be examples of different types of ways of traveling our network. So I'll try to go through them, and you have a summary sheet also that's going to kind of be done with this, and I've included that in Google Classroom and on Google Sites, so just make sure you're going through and looking at those. So please notice that I've labeled all of my vertices to begin. I just can't label that underline the last one because it's a little bit low for me. But the other thing I've included with my labels is I've included some shorter labels. So instead of just calling bridge, we can call it B. Instead of Fern Gully, we can call it F. Instead of gate 1, we can call it G1. So what we're going to try to do is I'm going to show you an example of a walk to start. So in a walk, you have a connected sequence of edges. So the edges must be connected. So if I started here at the gate and I first walked all the way over to the bridge, and I'll include some direction, and then I walked over to Fern Gully, and then I walked over to gate 2, and then after gate 2, I walked all the way down to the old tree, and then I turned back around and I walked back to gate 2, and then finally I went back to Fern Gully. So we'll just kind of do one last line there, and I went back to Fern Gully. All right, and there's my walk. So you notice in my walk, I've visited different vertices. The vertices must be connected, so I can't just jump between vertices. That would make it not make sense. It would not be. It would have ambiguity in our network. The other thing we can do when we have a walk is we can also state our walk. So my walk started at G1. After G1, I then proceeded to the bridge. After the bridge, I proceeded to Fern Gully. After Fern Gully, I proceeded to G2 or gate number 2. After gate 2, I went to the old tree, T, and then I finished at, after the old tree, I went back to gate 2, almost made that not make sense. And then after gate 2, I finished at Fern Gully. So there would be a way of writing out my walk using the vertices as well. So I've included all the vertices that I've gone through to make up my walk. Just take a second to note that a walk does not require all the edges or vertices to be different. I don't need to visit all the vertices. I don't need to visit all the edges. It's just me. I'm kind of just doing exactly what it sounds like. I'm walking around within a network. All right. So our next way to travel in a network would be in a trail. So again, I'm going to start over here at gate 1. So I'm going to start and I'm going to get walking over the bridge from gate 1. The big essential difference between a trail and a walk is that a trail is a walk with no repeated edges. So there's no repeated, that's not how you spell it, repeated edges. So if my writing is a little bit messy, it's hard to write on my phone, and I'm using my phone because it works a little bit better to be able to kind of write things down. So there's no repeated edges. So I walk over to the bridge. I then from the bridge turn and go to Fern Gully. From Fern Gully, I then head down to the gate. After the gate, I then continue over to the old tree. After the old tree, I head over to the waterfall. Oops, there we go. Over to the waterfall. After the waterfall, I head over back to the bridge. I still have not repeated any of my edges. And then finally, I return, or I go back to gate 2, but I don't repeat an edge. So that would be how you're able to do a trail and have no repeated edges. If I were to state the route I walked, it would be G1 is where I started. I went from G1 to B. After B, I then headed and turned over to Fern Gully. After Fern Gully, I headed down towards gate 2. After gate 2, I then continued to the old tree. After the old tree, I then turned and went to the waterfall. After the waterfall, I visited the bridge, finishing at gate 2. Oops, gate 2. You can see I'm separating everything with commas. Another way you can separate your vertices when you're writing these, I'll just use a different color for this, is you could also use a dash or a hyphen to do that as well. So if you wanted to, you could separate each one of these with a dash or a hyphen. That's how they did it in the textbook as well, and that's another way for you to write it. I've also seen in some resources I've watched them, they've used brackets as well. But there's a way of seeing a trail, and remember that a trail has no repeated edges, and that would be the most important part of a trail. All right, next one up is a path. In a path, let me just make sure I'm using the right color pen. Yeah, we'll use blue. A path is a walk with no repeated vertices or edges. So has no repeated vertices or edges. Sorry if this is a little bit messy. It's very difficult to kind of keep it neat. Okay. Has no repeated vertices or edges. So again, I'm going to start here at gate 1. There's my starting point. All right. So to show you an example of a path, I can't repeat any vertices or edges. So I'm going to go over from gate 1 to Fern Gully. From Fern Gully, I'm going to turn and head to the bridge. After the bridge, I'm going to head to the waterfall. After the waterfall, I'm going to turn and head down to the tree. And after the old tree, I'll head to the gate. And there is an example of our path. My path doesn't necessarily need to end where it started. If I were going to list my vertices, it would be G1. After G1, it'd be F. After F, it would be B. After B, it would be W. After W, I would finish at, after W, sorry, I would be at T. And then finally, I would finish at G2. If you would like this to look a little bit more like they did in the textbook as well, I believe that they use a hyphen between them. So you can see there's a hyphen between each one of them as well. That's another way to write it. You can also choose to include brackets if you wish. There is a path. All right, so a circuit is a special kind of path. In a circuit, you have no repeated edges. So I'll just write that down quickly here, that it has no repeated edges. So a circuit has no repeated, I've run out of room. No repeated edges. So I'm not going to overlap any of my edges on this. So again, I'll start here at gate 1. To do my example, I'll start at gate 1. To also say that a circuit's a special kind of path, it also ends up being closed. So it's a example of a closed trail circuit. Here, let me move all my stuff back over. I kind of shifted everything over. There we go. A circuit is also a closed trail. So let me just add that note here. It's also a closed trail. And this is important because a closed trail starts and ends at the same point. So if I'm going to start at the gate, I must end at the gate. So for my example, what I'll do is I'll start at gate 1. I'll go over to Fern Gully. The pen's getting out of alignment. From Fern Gully, I'll then head down to the waterfall, across the bridge, from the waterfall to the tree, from the tree to the gate, from the gate back over the bridge, and then to, oh boy, way out of alignment there, sorry about that. That should be back to there, sorry about that. From the gate, from gate 2 to the bridge. Now you'll notice I do have one spot where my vertices overlap right here at the bridge. I do have an overlap of my vertices, but in the end, my edges don't overlap. If I were to state my my circuit, it would be G1 to F, to bridge. All right, that's not a dash there. Let me just fix that really quick. Let's erase that. There we go. To F. To the bridge, from the bridge to the waterfall, from the waterfall to the tree, from the tree to gate 2, gate 2 to back to the bridge, and then bridge to gate 1. So you notice the important features here. To note that make this a circuit is number 1, or primarily what happens is you'll notice we start and end at the same point. So what we have here is we got gate 1 and gate 1. So starting and end point are the same, which does make it a circuit. We have no repeated edges. So as I look at my work, I can see there's no repeated edges. There is one point of overlap between bridge and bridge. And we will talk about that. That's a different kind of walk, but again, at the same time, a good example here, a circuit. Slightly different from a trail and a path, but key feature here is that it's closed and you have no repeated edges. I know in the textbook it also says no repeated vertices, but I'm going to get into a cycle in a second, and you'll see how a cycle differs from our circuit. All right, grand finale, the cycle. In a cycle will be start and end at the same vertices. So I'll just start with that. They start and end. Oops. They start and end at the same trying to get this the same vertice. At the same vertice. So they start and end at the same vertice. And then the other thing about a cycle that is important to note is that they're closed. So they're a closed path. The other thing is that there are no repeated vertices. So no repeated vertices. No repeated vertices. All right. So to show you an example of this, what I will do is I'll start at gate 2 to mix things up. Maybe I started my hike in a different location. I walk over to the bridge. I walk from the bridge to the waterfall. I walk from the waterfall to the old tree. I walk from the old tree over to the gate. And there's a quick example of a cycle. So that would be G2 to B to W to G2. Quickly, so to review, and I'll see if I can just add another one. So important things to recall are things, the difference between a walk. So a walk, you have a trail, you have a path, you have a circuit, and you have a cycle. And each one of these has kind of small differences. I do highly recommend looking at the table in your textbook that kind of summarizes all of them, because it's really, really great. But it's walk has connected edges. Showing a route, so it shows the route between vertices and edges. A trail has no repeated edges. Sorry if that D is the messiest D on earth. A path has no repeated vertices or edges. Vertices or edges. Sorry if I'm writing those as short form, but I just don't have room. A circuit has no repeated edges and starts and ends at the same vertex. So no repeat edges, no repeated edges, the same start and end. Same start and end. With a cycle, it has no repeated vertices, so no repeated vertices, and they have the same start and end as well. So the same, I'm gonna run out of room, same start and end. Sorry if that's really messy, but there's a really good overall traveling network summaries in your textbook. Hope this is good. I'm going to include a different video on transversal graphs after.